right, good morning, everybody. Sorry for the delay. We will get the show on the road. I'll make it short and get Dr. Sorensen up here. He'll go through his case and his presentation. My name is Ed Hafke. I'm the National Sales Director for Besmile here in the United States. And we're going to do a couple things this morning. I'm going to just do a real brief who we are, right? I think a lot of people never heard of BSM or Besmile, which I didn't, and I've been doing this for a long time until I came over here and joined this team. So, we want to be the leader in the digital solution provider in the worldwide. And I think you'll see that or hear that a lot from the digital companies nowadays. But what's interesting, and this slide here was when I first came over here. I've been over here for about a year and a half. And before that, I never heard of Besmile. And I started looking at their company history. And if you look here, they actually started in 2003. And then they were actually an orthopedic company, and then they kind of progressed, and then they were in exploration, and then we got into the expansion. And in end of 24, beginning of 25 is the first time they came to the United States. So up to that point, we were already in different parts of the world. We're in 100 countries. We've helped 50,000 patients over the last 20 years. We do attend global exhibitions all over the globe. And the program we're doing today is the Global Seminar Series, right? So we do these types of programs all over the globe. We have our academic network, which includes Dr. Sorensen, Dr. Z, and Dr. Suzuki. These guys are instrumental in giving us feedback, helping with working with the FDA and going through all the regulations and making sure that our I's are dotted and our T's are crossed when it comes to regulations. And just the quality of our materials and honest feedback. We spend about 20% of our staff and 20% of our annual resources on R&D, which I think is great, and it's earned us, some patents. We got a lot of FDA cleared certificates. We have 100 trademarks, some copyright stuff for the software part of things, but they've invested a lot, and it really shows when you start working with them. For me, having been in dental my whole career, it's been a breath of fresh air, just the way that they work, the dedication to excellence, which is it's awesome. And I think you'll see some of that in Dr. Sorensen's case that he's going to present today. This is a little bit about our manufacturing. We have capacity to make about 1.5 million discs a year. We do some glass ceramics. We do make our own mills. We make our own ovens in-house. We do about 1,000 pieces a year there. And implant components. We don't have a milling center per se. But we do a lot of milling for local China. And in that operation, we're using our mills that we sell, right? So we have 200 milling machines every day just grinding stuff out. We've sold about 3,000 machines around the globe, including here in the States. But the number that kind of stuck out with me with this one was, we do 3,000 custom abutments every day. And we're milling those onto 420, our 420 and our 520. So it's, the machines that we're selling have been proven. I mean, we've used them, broke them, used them, fixed them. So when I'm talking to a customer about a machine, I feel very, very confident they're going to be successful with it. So it's great. Tech service, I get this question all the time. In-house support team, 16 hours a day, 7 days a week. They're on the phones. If you need something tailored to your site, we can do that. If we need to do an on-site visit, we do regular follow-ups. We do regular follow-ups, actually. And technology creates the best smile. So with that, I'd like to introduce Dr. Sorensen. He is the director of B4T Laboratory. He is also the director of research and graduate prosthodontics program at the University of Washington. He's got 40 years of clinical experience in the implant-supported prosthodontics, including in serving as the managing director of Clear Choice Portland. He brings a great deal of experience in the full arch world. For the past 13 years, he's taught at the University of Washington. graduate cross program residents of both conventional and digital workflows. I'd like to welcome Dr. Sorensen.
Well, good morning, everyone. It's a pleasure to be here with you. Apologize for my tardiness. I have not been working with the company that long and have been spending a lot of time both doing clinical work with their systems as well as getting educated on it. And I do have to say that I'm pretty excited about working with the company. The way I got involved with BSM was one of my favorite people in the dental school that I taught classes with, Dr. Hai Zhang. Turns out his hometown is Chengdu. He went to dental school there. And he connected me with BSM, and we got to go visit there in December of '24. And I have to say I was very impressed with the company, both in terms of the facilities, their dedication to R&D, their big investment. A lot of companies, almost no companies invest much money in R&D anymore. And so it was really refreshing to see what they're doing. So if I could get those batteries, Ed. Here. AAA batteries. So I bring greetings from Seattle and the University of Washington. I asked for them yesterday. Ed was supposed to give them to me. No, I need 2 AAA batteries. That I had asked for yesterday. So why would I want to get involved and work with this company? Well, like I was saying, they have a big, and are highly dedicated in terms of their investment in research and development. They definitely have a vision for where the company is going. And after I visited there, they are a very highly innovative company. And then when I found out about their Aconia 3D Master, I was very impressed, and then going back and forth maybe 8 or 10 times with me asking questions. Thank you very much. Just to, great, thanks. I was very much impressed with their material. There's probably only one other material on the market that that can compete with the aesthetics that you can achieve with this, just based on the inherent optical properties of the ceramic. And so we're going to go over that, and I'm going to say that they're very serious people. They do their homework, unlike a number of American manufacturers that have very pretty advertising, but they don't have any research validation for their products that they are expecting doctors to put in their patients' mouths. I like working with, I'm going to call them startup companies. I started working with Ivoclar in 1990. They were Ivo Who. They had 9 people in the company. I did a 5-year clinical trial on Empress. Worked with ITI, which later became Straumann. I co-invented the octabutment for the implant. I was one of the original 16 speakers for the company. Worked with SageMax, which was a company in Federal Way, Washington, and Larry Tang started his company, and they grew over about 7 years from producing 6,000 zirconia discs a month to about 60,000. And then they got bought by Ivoclar, and then Biodenta, which is a digital and an implant company. So I like being on the ground floor and working with these companies, and I think this company definitely has something going with it. So again, I'm at the University of Washington. I started my 14th year, and I moved up there from Portland, and in order to revamp the clinic operations and the curriculum, but I really wanted to get up there to start developing clinical research and trying to develop completely digital workflows for like the All-on-4 system. I was director of the graduate prosthodontics program at UCLA for 10 years. Had some amazing residents, including Ed McLaren, who started a master dental ceramist program at UCLA. And I'm very concerned for our specialty. So could I have a raise of hands for those of you that are technicians? Great, good, okay. And I applaud you, and you know it's very competitive out there, and you know one of the things that's going to make you more competitive is your knowledge base on these materials and your expertise. I'm happy to have you here for the program. I was lucky enough, John Bumer, my department chair, invented the UCLA abutment, and it was just an amazing time. We had the synergy with this group, and these 2 guys were skulking around in the hallways, and it was Keith Beatty and Richard Lazar that started 3i Implant Company. They've gone through like 4 name changes, but it really was an amazing time. And then I got an endowed chair at Oregon Health Sciences University, built a clinical research center. We had about $500,000 in clinical studies going on as chair of the fixed pros department. We got a new dean, and I was full-time faculty number 16 to leave the school out of 46 people. Somehow we were all bad people. Pretty dark days, but I ended up starting my own institute about the same time actually John Coyce did. Had a full-time pros practice, in-house technicians, and did clinical studies as well as doing CE courses. So I had in-house technicians. They're expensive, but for me it's worth the investment of having that talent working with me in-house as a partner. I only hire technicians whose names begin with a K. And and Kyle was actually trained by Ed McLaren as well, and really have always had worked with in-house technicians. We did again have a lot of CE courses, hands-on courses, as well as live patient treatment courses, and visiting researchers, including Florian Boyer, who's a professor in the university in Berlin. Very promising young man, and has done really well. And Daniel Edelhoff and Florian Boyer and I are writing a textbook together, and that's moving ahead by leaps and jerks. So I was running this task force, And then my personal mission then was to utilize modern materials and digital technologies to develop standardized digital workflows for procedures for both conventional and implant-supported prosthodontics. So I worked with a number of companies on various digital technologies. Kind of the main thing at that point was cone beam CT, so we could work in 3D. So I was at Third Choice Dental Implant Center from 2009 to 2012, and really enjoyed this. We were doing about 225 arches a year, and I saw a definite promise with this technique and wanted to then turn that into looking at the digital materials and the technologies that could help us do these various things. So I was at the IDS show in 2013. A good friend, Urs Brodbeck, a prosthodontist in Zurich, dragged me over to this booth of the Biodenta company, and they had some engineers and some dental technicians who were very advanced in digital technologies, putting those things together, and I got connected then and discovered the 3Shape Trios intraoral scanner, which is amazing. I had, again, in the 80s worked with CEREC 1 and then several other systems, and this was, I was going, wow, this is really something that we can work with. And again, we've been trying to develop a totally digital workflow with this, and so we had come up with a device that would give us like 8 major factors for what we need to know in terms of designing a denture. And so we went over and met with the folks at 3Shape in Copenhagen, and told them what we wanted, and they're going, oh man, this is really challenging. You guys want to do a moon landing. Turns out that the software bridge we wanted them to develop was actually, they had been doing something for Ivoclar and have been dragging their feet, but they came up with, I don't know if any of you were working with the 3Shape complete denture design system, but it's fantastic. So we ended up not being able to work with them, but one of the things I also wanted to do then was to build a world-class research lab with prosthodontists, dental technicians, and some engineers. We've been investigating all of these materials and so on. And I am lucky enough, as probably the highlight of what I'm doing at University of Washington is being director of research, and I'm mentoring 5 master's degree students, and very smart, I'm going to call them kids, really dedicated and just a joy to work with. And so we've been doing a lot of work, and of course we can say now, I think we're pretty sure that for single tooth intraoral scanning, we have very reliable systems. There's probably 30 brands out now. I mean, even the Shining 3D for 6,000 or 7,000 works just fine for single tooth restorations. But once we start to think about this process that's a lot more complex, and then working with different specialties and so on, it gets a bit more complicated, but it's also, there's a number of steps that digital technologies and digital materials can help us out with these procedures. So whether you're doing conventional fixed prosthodontics or complete arch oral rehabilitation, with whatever, we kind of have these basic steps that we go through as we are proceeding from our original treatment planning and assessing our patient, and going through this iterative process with the provisional restorations and the prototype before we make our definitive implant-supported, expensive prostheses. And so it's the same whether we're doing conventional or implant prosthodontics. And so what I've been lucky enough, each one of these has been a master's degree study I've been doing with the students. I won't go into all of them. We'll just go kind of to some of the highlight studies as we're going through this. I'm gonna cut out a whole bunch of stuff here, and we're going to kind of get straight to the topics here. And so we're going to spend a fair amount of time going over zirconia ceramics. I'm going to probably give you more than you wanted to know, but I'd like to kind of establish what the limits are of these materials, what the capabilities are, and we'll kind of go through what I think are kind of the 4 or 5 leading products that we have available to you, the technicians, in order to make aesthetic monolithic zirconia restorations. So we have something that is very reliable, and especially as we went through that painful process of when the original, like the lava zirconia came out, we used it as a substructure, we were veneering material on it, and of course we were being very stupid in that we have programs for sintering our ceramics on metal substructures. We're using that same firing process, temperatures, climb rate, hold rate, and so on, that we would use for metal, and now we're going to apply that to a zirconia ceramic material that has a very low thermal diffusivity. And so we were having problems with the ceramics veneering material fracturing off. The Clinical Research Associates was saying they had a 50% chipping rate. I got into a little throwdown with Rella Christensen, and she said, well, our technicians are sintering at a lower temperature, and I'm saying my guys follow the directions, and so we had about a 4.5% chipping rate. And then, as with all these various developments that we've had within our system, my computer is a little slow today, we finally catch up with how we're working with materials. And have something that is very reliable, and we improve those situations by going to monolithic restorations so that we will not have anything that is going to chip. So let's go over those zirconia ceramics then. And again, we've been working a lot with this material. I started working with lava zirconia in 1998, and then with a number of other systems that we've been going along. So we were doing a study for Ivoclar, codenamed C499. So this was a precursor for Emax material. So we had done a study when I was at OHSU on Empress 2, which is also lithium disilicate. This was a modified formula. And we were doing posterior bridges, full contour, a little staining and glazing. And in that study, then we developed and invented a bite force measurement machine. And if you take the bite force at the central incisors, when we found in our measurements that if you go to the second premolar, it's double that bite force of the incisors. And on the second molar, it's 3 times. So then obviously the forces that we have on our posterior teeth are considerably higher. And of course, if you want to use them for bridges, it's going to be even greater stresses on that material. And so I have been working with a number of systems from the very beginning, back in the painful 80s with Cirrustor and Dicor that had 35, 40% failure rates in the first year. So we were a little reticent when we wanted to start using these materials for bridges on there. So in Ceramolumina, Empress 2, we're looking at 10 or 11% failure rate, so definitely not strong enough for that. When Daniel was on sabbatical with me, we did a little study, and we looked at the flexural strength of the basic systems that were out there. And you can see pretty typical values for Empress 2, Inceram, Inceram zirconia, which was about 40% zirconia, and then lava zirconia. Wow, knocked our socks off, over 1,000 megapascals. What we then did was to take those samples, a group of samples, and we're going to store them in water for 7 days. So again, in the mouth functioning, we're talking about being in saliva all the time and the breakdown that goes on in the ceramic structure with that. But look how much the strength of these ceramics dropped when we had it in water, again for that 1 week, that 7 days period of time, where we're seeing pretty significant drops in the strength of the materials. Even with the Inceram material, a big drop off. And then what do you know, but some of the zirconia, it was again not completely zirconia, we had no statistically significant change, and also then for lava zirconia, it was not affected by moisture. So now we're starting to go, all right, we have a serious material here that really will show some promise. And again, back then we were doing it as a veneering material. So this is my experience in doing clinical trials on bridges in the premolar area, 11%, 10%. Then the Emax pressed material, about 10%. But what do you know for the lava zirconia with 46 bridges, or the Emax Zircad zirconia, we had 20 bridges, and again, no catastrophic failures. So there really is something to this material. And now if we start to look at, we're going to be talking a lot about full arch implant supported restorations. Pretty famous guy, Paulo Malo from Portugal. He has a factory where they're treating thousands and thousands of patients a year. And so they published this paper, and interesting, 7-year clinical studies, 5 years radiographic, where they were looking at this digital workflow here. So they're going to have surgical guides, placing the implants, and then doing immediate provisional restorations. And it looks like they're not laying any flaps here. And they reported a very high success rate with those. So they were looking pretty good. But what's a little scary for any of us that either have a lab or we're in practice, 30% of those patients had mechanical complications in the definitive or final restoration. Okay, so 21% of those experienced fracture of the definitive prosthesis. So we're doing hybrids, a milled metal substructure that is supporting typically the PMMA acrylic material with denture teeth on there. And then some other things, screw loosening and some other minor things on there. But imagine 1/5 of your patients, 1 out of 5 of your patients are coming back to your office all pissed off because they paid a lot of money, they went through a lot of blood and sweat on this to get their implant surgery, and they're having teeth fracture all the time. So we had a much lower rate at our Clear Choice Center. We were at about 4.5%. Still, it wasn't a whole bunch of patients. It was like the same patients that broke a tooth, fractured a tooth, chipped it off, and so on. Again, this was the standard of doing hybrid, which we had done hundreds and hundreds of arches of this, but makes us start to think about, well, should we look at other materials? So I was working with, it's called Burbank Dental Lab, Andrew Sedler, the Advanced Technology Center. He had developed some great systems for being able to make design and make milled metalwork, and we're doing metal occlusals for those patients that are fracturing. And then we started to work with Enrico Steger, and if we look at the work that was done at Tischler Dental Lab, where they're using all Zircon-Son materials, Avi Bidra, the director of the Grad Pros program at UConn, then went in and analyzed their data, 2,000 arches in there, and had a very, very low failure rate, less than 1%, maybe 2%. but very reliable when we maintained and had the right vertical height of the material, as well as handling the material properly. But they did all monolithic restorations of frameworks or bridges, and the material that Enrico Steger has, the pre-tau materials, has a flexural strength of about 13 or 1400 megapascals. So it's even extra strong, but this is starting to make me feel pretty good. I mean, we experienced it, you know, but to see this large number in there, and they guarantee their restorations, were that this seemed to be a very reliable mode of therapy on there. And they'd have problems when they didn't get those sufficient dimensions of the material. And then also, I don't know if this looks very good, it doesn't look very aesthetic to me. So now that we have this incredibly strong material, how do we make this opaque material more aesthetic? And that's kind of what everybody's been doing, and has been doing, and are what we're able to achieve, again, with the inherent optical properties of the ceramics has improved tremendously for what we have available to us. So again, I have to admire, I started out on the scientific advisory board for ESPE. They had great scientists. They're actually the ones who invented the zirconia and the milling system and everything, and then they got acquired by 3M. They had the patent on what they call doping, where you're basically taking this milled framework that is the consistency of chalk, and you just drop it in there, and if you just want to do a basic A3 shape, you leave it in there for a certain number of seconds. It absorbs it all the way through the material, not just a surface phenomenon. And then you have to sinter it anyway, and that's kind of cool now with the number of systems where you can significantly shorten the sintering time. But a very effective system, whether you want to do a basic shade or if you want to get fancy and do different characterizations of your restoration. And again, I have to acknowledge Enrico Steger for developing his aquarelle system, pre-sintering staining. So you have to sinter it anyway. And in order to apply these pre-sintering coloring, it doesn't take that long. You know, anybody can do this. And again, you can get as fancy as you want as you are applying the material. So again, Enrico has the basic Vita shades, and you just go ahead and put it in the bath and then paint it on there. Again, you have to fire this anyway, so why not get a little creative? And that takes, you know, 2 minutes for a single restoration, or you can do an arch of 14 units in about 20 minutes and get pretty fancy for it, and get these really nice improvements just in the optical properties of the material. So you can have a dentin shade, you can put all sorts of characterization in there that will then help you to achieve very nice, very aesthetic results with the material. And again, it's not a surface phenomenon, it's within the material itself on there. So a very simple process to, again, paint this on, whether we're doing anterior restorations, which I honestly, if I'm doing a single anterior tooth and I have a very opaque dark tooth, I'm probably going to use zirconia to block that out, but I'm probably going to do some micro layering of 3 or 4/10 of a millimeter, or use the Mio material in order to achieve the aesthetics. But for milled out full arch or single restorations, this is a no-brainer to be able to use this material and go ahead and get pretty fancy and really bring these restorations to life with them. And again, you know, you can get as fancy as you want, but also nice that you can colorize your gingival area too. So originally, Enrico was doing copy milling, so this is one I think I did in 2008 or 2009 with him, and then they got a little fancier. This particular patient, we had screw access holes that were coming out to the incisals, so we had this framework, and then we cemented individual zirconia crowns, but very nice looking, very natural restorations on there. And then I was just thinking about one of my patients who is one of those you never forget in your practice, and within 18 months, Denver fractured 2 teeth, then came back and fractured 1 tooth, then chipped incisal edges of 2 teeth, and then fractured off a big chunk of the PMMA base. So again, a potential problem like Malot's group was having with their materials, and he came out then with this pre-tau material where, again, you're applying this and it soaks into the material and can give you very nice aesthetics that are, again, within the material that are not going to wear off with toothbrushing or being in occlusion or whatever parafunctional habits your patients have on there. And again, just really natural looking gingiva on there, gingival base as well as the teeth. And very importantly, we are going to use abutments, and we actually cement these intraorally so that we have a passive fit. Yes, the material is very strong, but we also want to make sure that with this cementation procedure, we can have that adjust and adapt to whatever the situation is. The one thing that I will talk about later is that a lot of the stock tie bases are only 2 or 3 millimeters high, and we often have implant crowns that are 13 or 14 millimeters long, and the same thing with your prep to crown length ratio. We want to use abutments that are taller than that for these. So with this, we really have a great interaction, or actually potentiates what we can do once we have these standardized systems for implants and how they can be advanced with the digital technologies and the planning for those. So then there's also something to think about in terms of the processing, how the company makes the ceramics. So there's huge differences in the quality of what the raw zirconia, how the companies process it. So they were able to take the lava with 11 to 1200 megapascals flexural strength, and then reduce the contamination in it, and then they were able to increase the fracture toughness and get a higher translucency, yet still have the strength. And that's the Ivoclar material. They kind of gave it a, it's just called zirconia on there, but they've also done some very interesting things in how they are processing their material using a high strength of 3Y, but making something that, excuse me, is more translucent. So we want to think about how homogeneous these are there contaminations in there, and they went to a finer particle size actually to increase the translucency of the material. And again, we're using the coloring solutions to characterize those restorations. Again, whether you want to do single coloring or get fancy and then polish these up. So zirconia is the most highly machinable material that we have in dentistry besides metals, and it's also highly polishable. Again, these were just applied pre-sintering on there to get those colors. So I was testing out the Lava Plus system, and I made this 3-unit bridge. I was replacing one that existed in there. Did, again, all pre-sintering coloring. Got a nice warm dentin appearance on that. Again, no external coloring on this. And then also it just looks nice. I mean, it's not as translucent as lithium disilicate or Empress, but still very nice looking. So we're going to always use a red banded 30 micron finishing diamond anytime you are grinding on, well, all your ceramics, but especially with zirconia. And so Brasseler has a very nice, it's called Dialite, and then they have a ZR for zirconia, and then Dialite LD for lithium disilicates. So I can actually, with this burr, I can go in and grind occlusal anatomy as long as I'm not using too high a pressure. I don't use water when I'm doing that. And I can go in now, and here we're going to adjust the occlusion. So I'm using my red banded 30 micron finishing diamond to adjust that occlusion. And now I'm going to polish it up. So just to show you that, again, this is within the material, is now I'm going to take the blue coarse dialite polishing system. This is back with that original 3-step system. We go to the medium, and then we go to the fine, and what do you know, but we still have our colors in there. So again, now all the companies have these systems that are available, including what we're going to be talking about with their system today. But again, I just get this nice depth of translucency, a warm dentin appearance on the occlusals that looks natural. And then we're going to go ahead and cement this with the Unisem cement. All we want to do is either aluminum oxide abrade the surface with 2 bars for the zirconia, or use the IvoClean material, which you just paint it on there for 20 seconds and clean it. So whenever I lectured for laboratories, they always go, Dr. Sorensen, you have to talk about cements because the doctors are always asking the labs, well, how do I cement this and so on. So again, a very simple process, and again, strong enough that I can use the dynamic seating method as described by Gigoff and Rosenstiel to get this seated all the way down into place, and have, again, next to a PFM there, something that looks natural with very little effort expended based on the properties of the system. And like the world's most famous man here, even when the odds are 50-50, he has a 98% chance of victory. And that's what these zirconia materials are doing for us now in our clinical work. So everybody's trying to make systems, zirconia, that are more translucent in there. And let's just go a little bit of science 101 here. So basically, the zirconia is normally in a monoclinic form, and we want it to be in the tetragonal form. And what they do is they add some yttria to that to stabilize it. And when you do that, then you have this amazing property called, in that it increases the fracture toughness of the material. It's called transformation toughening. And when you have the energy of a crack that's trying to go through that, then it causes the expansion of the particles of somewhere between 3 and 5%, and that pressure of the expansion of those then closes off the crack and increases its fracture toughness. That's the resistance to the propagation of cracks. So if you want to make it more translucent though, what we do then is we add some cubic zirconia to that, and we do that by increasing the yttria content. So standard high strength is a 3Y, then we can do a 4Y, which is 25% cubic zirconia, or we add 5Y material increase in that, and we then get a 50% cubic zirconia, and now you'll end up with something that's as translucent as medium translucency Emax material. So the problem is once I get up here, I have 50% cubic zirconia, I no longer have that transformation toughening phenomena. Now, if I have 600, 700, 800 megapascals, no problem for single crowns and probably okay for a 3-unit bridge. But what we're talking about today for full arch implant supported restorations, we probably want to stick with the 3Y, or see if there's some ways that we can modify the formula for the processing and the design of that in order to improve the strength of the material. And again, we'd still like to have some of that translucency. So with the current technologies then, we can achieve a number of these elements just by how we design the system. And as Willie Geller told me, unfortunately he passed away last year, and he goes, you know, John, getting the form of the teeth is most important. more important than matching the shades. So if we are able to use these design technologies and have nice occlusal anatomy, or on anterior restorations be able to create the surface texture we want, we're going to get that much closer just by the form that we have there. And now with these materials that we have available to us, then we can go ahead and hopefully improve the strength of these materials enough that we can make them aesthetic. And like I was saying, everybody has coloring materials for their systems that I would definitely recommend if you want to have a higher level of restoration. And in your labs, you might want to have your production numbers. I don't know if you can compete with $29.95 for a crown in there, and then maybe you develop, that's what's covering your overhead and making your money for you. And then maybe you have a kind of a master's division there where you're doing more, putting more time and expertise on that to be able to get a higher level product. So we have been playing around back a while ago with the Lava Plus system, and again, pretty nice translucency with this material. I was doing a case with one of our grad pros residents. We had Burbank Dental Lab mill out chrome cobalt so that we can then apply opaque porcelain, and porcelain to that, forget titanium, don't go there, you get too much oxide formation and it debonds. And we're going to do this crazy thing where we have tooth colored opaque on the tooth preps, and then we've got some pinkish on there in order to have something that provides a color a basis for us in terms of the gingival materials. So we're going to be using all monochromatic there, and you can get away with that when you are doing all the units in the bridge that are all the same shade and opacity or translucency levels in there, and really produce some very nice aesthetics with our material that look very natural and can give some nice results for us. She thought she was Miley Cyrus, and just a blast to work with this type of material. We were 10 years ago with Carlota Suarez, who's back in Madrid practicing. And so there's a lot of things we can do even with those basic shades, but imagine what we can do now with these expanded coloring materials or ceramics. I'd like to show you a case I did with Jack Kiesler, where we were doing retreating a full mouth rehab. Unfortunately, a lot of the teeth had caries underneath it and had to be extracted. And so we have a number of ways that we can do our treatment. Jack, against my better judgment, he wanted to do 4 sections of zirconia bridges. And I think that's pretty crazy, because what then happens to me, if I'm going to have to take out all these teeth and put implants in, I now have my hands tied in terms of having to observe and try to get my match with my gingiva. I'd rather do the full arch prosthesis and have the control of that so I can get perfect gingiva and not have to worry about getting recession or whatever else that's going on your implants there. So he wanted B1, okay. We'll test that out with the provisionals, and we basically have kind of 4 levels that we are analyzing our aesthetics for our patients, whatever facially generated, a very important lip dynamics, smile line, and all that, and then typical prosthodontic procedures that we work all the way down to the individual tooth. So we do our smile analysis, and he's got very challenging there. He's got gingiva exposed and recession and so on that's going on, caries on almost every tooth, teeth fracturing, bridges fracturing as well. And so we determined that we were going to have to take everything out. And again, the treatment plan was doing extractions, implant placement, and then doing the segmented fixed partial dentures there. So we'd have four bridges as we're doing that. But again, as I was saying, we've got the same limits as natural teeth. Why do I want to go there with fighting all that? Again, when I can control it with the prosthesis and how we're doing. So we went ahead and actually designed with the 3Shape software, the provisional restorations. We milled those, designed and milled those out. And then on the day of surgery, gave him immediate provisional restorations. We did with using scan bodies for this. We're eventually going to take these teeth out, but the plan was to get these implants in first. And here we're working with the amazing Jack Jung at 3D BioCAD. We're lucky we have them in the Renton area, not too far from our dental school, to go ahead and design the restorations from where we want to be. And then now we've got temporary abutments that are very rough. Will engage the acrylic, and we'll have no problems with that. And we've already got a nice improvement in the aesthetics with that, where we're actually almost following the smile line. We've got to do a little modifications here and there, but we're much closer to where we want to be for his aesthetics and the reverse smile line that he had with that system. So we're going to go ahead then. We're going to test out these provisionals. Those are our prototype, and we get the patient's feedback, and then we can go ahead and make our recommended changes we want to make in contours, length, and so on of the teeth. And then from there, either make a prototype of that's going to represent all these changes before we go to the zirconia restorations, or just throw it to abandon and go ahead and make it directly for that. But again, our provisionals are always our prototype for our final restorations. And here, with the 3Shape system, we've designed our teeth. One thing I don't like about the 3Shape system is you can always tell it's their design system, because the zenith and this facial proximal line angle here goes to the middle of the tooth, and it should be going down here, but that's an easy thing to correct on the software design. And then we had Lee Culp make the bridge for us on the lower, which was the Emax Zircad Prime for that, and then the individual crowns on the tie bases for the upper levels on there. Again, monolithic here with the prime material, which we'll talk more about that later. It goes from 3Y to 5Y at the incisal edge, and then provides nice aesthetics, even if it is a B1 shade, and something that the patient is very happy with for that. So a nice improvement, but again, we started having problems with this later on, where we had debonding of the segmented bridges, because several of the stock tie base abutments were only 2.5 millimeters high, and of course that's not going to support in the long term those bridges that are on there. So we've been working with monolithic ceramic restorations, so we don't have to worry about chipping. And then what I think we're after for our profession is, or for the artists, is to provide fabrication technologies and ceramic materials that, by their own inherent optical properties, will make an average technician able to get good to great results. And yet for the artists, they can still take that even beyond that for those materials. So we'll talk about the evolution of ceramics. And part of this is, as they say, as Degas talked about, art is not what you see, but what you make others see in there. And so if we look at what we're doing with our materials that we've had and we're working with now, we're trying to manipulate the brain's tendencies and assumptions that, let's say we have translucency where we don't really have any on there. So is this onlay, is it really translucent, or is it just colored that way? Or with these teeth, are they natural teeth? Are they translucent ceramics, or are they zirconia? And we're able to color those inherently so that they have great optical properties. So we'll just kind of quickly go through these systems. So the main one has been a shade gradient. So that is, you might have a 4Y zirconia, and you have a dentin shade, you have transition A and B, and you have an incisal shade in there, but it's only by the pigment particles, the color particles that are placed within that ceramic. Katana, a very, very popular system, and it's a good system, but there's not quite the same optical properties that you get because, again, they achieve these aesthetics by the pigments that they put in the ceramic structure. But again, pretty nice looking material that we have to work with, and they have these layers in here in order to achieve that. Something that I think has been a really fantastic invention is the Mio material. So my good friend Don Cornell, an amazing technician I've worked with over the years, they bought Chemicale, which was one of the original ceramic engineers for Ivoclar, went down 1.5 kilometers and started Chemicale, which made private brand label ceramics. They weren't doing very well, but they had two amazing ceramic scientists there. And so he came up with these ideas, these concepts of what he wanted. And so then his two ceramic scientists took a couple years, but they were able to come up with a completely different approach for the aesthetics of ceramics, what they called a liquid ceramic on that. A couple of things that are amazing about this is what you see is what you get. So when it's sitting on there, the colors are, well, number one, they're not flowing or running, they stay in place. But what it looks like when you have applied these materials and when it comes down on the oven looks exactly the same, which is, I don't know if any of you have doing staining and glazing, but that's a problem. I mean, it's always running on there, and so this was an amazing material. Also, with this material in a couple hundred microns, 100, 200, maybe 300 microns, we can create this incredible color and depth of the material. So especially, I love this material for the gingiva on there, because a lot of the perfectionist ceramics will use a monolithic zirconia and color it and everything, and then they'll apply powdered ceramic on there in order to get that more natural appearance. So this material has very interesting solvent properties, that it does not evaporate and it stays for a long time. So Don Cornell and James Choi, amazing technician that my boy Ed McLaren trained, just an unbelievable technician. They spent a week with us and we were treating Dr. Su's patient we'll talk about, and then also another time they were there, we did a bake-off contest with 5 different substructure materials using this material. So I think it's Tuesday, and I'm going to take these guys out for sushi. My favorite sushi bar, if you're ever in Seattle, is under John Coyce's training center. It's called I Love Sushi. And so we're running around. They're working on it in the lab to get the substructures ready. And so I get down there, and James has applied the material on these 2 teeth, and I'm going, we can't go for dinner. I mean, you gotta finish all these teeth. And he goes, no, John, wait, don't worry. So we go ahead and we leave at 6:30 to go have sushi. This looks like this, nice and shiny. We come back at 8:30 in the morning, and what do you know? It looks exactly like he left it the night before. So this is really an amazing material, and everybody's trying to copy it. I don't know that anybody has yet. This new material from Ivoclar is looking very interesting, but it's thicker than this material, but we'll see. It's looking like a pretty nice material. But this has been very popular with our prosthodontic residents and my famous kids in the back of the room here, in that you can use it on lithium disilicate, you can use it on zirconia, and again, something you can master pretty quickly for that, and then also get some very nice properties. So we can use it to do single crown aesthetics, achieve the surface texture that we want to match the individual teeth, and get something that looks very natural, even with a patient like this that has all these kind of funky things going on in her teeth. And actually, I'm lying, these are 2 3-unit bridges, and again, very nice aesthetics that you can achieve with monolithic zirconia. And you actually are breaking the rules that you think of as normally we always want something that's more translucent, and we're building on top of that, like when Willie's Glass or Willie's Creation was around. But in this case, with this material, you actually want it to be white, opaque, and then achieve your coloring with the application of the system. If you use a more translucent material, it always ends up too low in value and bums you out because it looks really beautiful, except it's too dark to match to the teeth on there. So we were looking at a number of different materials, but again, this is the color we want for that foundation material, not something that is a real translucent, and you can build the surface texture whatever you want for that. And again, just kind of disappearing into the gingiva, looking very natural for that material. So for me as a prosthodontist and what our residents are doing, and probably you in your practice, for me, from the provisional restorations, everything else follows. So this is going to be about 75% of the work I'm doing in fixed prosthodontics, especially with full mouth reconstruction, is I want to test out that proposed design and function. It's a great communication tool for our patients in there. And so it can serve very importantly as a prototype for our restoration. In this case, for Leslie, this patient, we went through 3 sets of provisionals before she was happy with the restorations. So what's really cool about this, and again, I want you to think about this in your lab work here, is pre-centering coloring. We have to center it anyway. And he's even got little root prominences in here like you're doing a denture, dentin shade, translucent enamel, and something that and has purplish color for the gingiva on there that gets you that much closer to a natural looking restoration. Again, you have to center this anyway, and it doesn't take that long to go ahead and do that application. Once we have centered it, now we're going to apply the Mio color. Again, we want to get our color with that. Again, you can build in any characterization that you want, and then also you can get fancy and have different colors in the gingiva for that. You're going to go ahead and center that, and then you now apply the structure material. And this material is viscous enough that I can take a brush and go ahead and make stippling in there, or I saw somebody doing a demonstration, and this technician was using an endodontic file and making little pits in there, okay? It looked very natural, and you can also, and that's one of the problems our residents have, is they don't apply the structure, and so they have a very smooth surface, and the surface texture does not match the natural teeth. So just sensational results that you can get with this material that has been very promising and helped us to achieve very nice results. But we'd still like to have more translucency, more depth in our actual materials, and so a better way to create an aesthetic restoration is to have a gradient of ceramic microstructure. So now we're going to have something that looks more like the natural tooth. Ivoclar was one of the first ones to come out with this. They had their different translucency materials, but they then came out with the multi-material, which had a flexural strength of about 850 megapascals. So pretty good for that. And they would transition from a 4Y to a 5Y. And now just by the basic structure, the crystalline structure that I have in that disc and how I want to position or nest my crown in there for how much translucency I want, I can achieve a nicer result. So I probably worked the most with Lee Culp for 30-something years on there. And so we can actually go in and instead of, what Ed teaches there is to do all this grinding and fooling around with the restoration. You can go in there, and what Lee has done is created the surface texture on these teeth for this to achieve not only the color from 4Y to 5Y, but a natural surface texture so the light's reflecting similar to the natural teeth on there. So with Min Soo, one of our grad Frost residents, we did a study to look at 3Y, 4Y, and 5Y materials, these different discs, and when they were layered, we'd go in and in that material take cut discs and create test specimens in there to measure the biaxial disc strength on that. And here we have 3Y, we have the percentage of cubic zirconia in there for 4Y and 5Y. And we found good strengths for these materials. And we have a problem, though, in that we saw that the flexural strength dropped about 36% for the 5Y material when you aluminum oxide abraded it. So you do not want to abrade the material. Just use the IvoClean material, easy peasy, paint it on there for 20 seconds, rinse it off and dry it, and you're ready to cement your restoration. And just to discuss, and then we won't go when we go through our clinical cases there, but right now we know that that MDPs are so far the magic sauce to give us a chemical bond, not as high as etched ceramic, but it does give us a fairly reliable chemical bond between the zirconia material and whatever we are gluing that on, whether it's natural two structure or it's our abutments that we're going to be cementing on there. So with Janos Vitsas, we did another study. I think I've done 4 studies now with tribochemicals, silicas, spraying it on there. Don't waste your time with it. But we found that of the major cements, 2 of them, Speed Sem from Ivoclar, which is they have a dual curing material, and Panavia, whatever, they change the name every year, but it's a great material. You do not need a primer. You have enough MDPs contained within the cement that it will give you adhesive bond strength to the ceramic. So again, in this case, we're delivering the bridge. We're going to go ahead and use the Speed Sem material and again clean that surface, and then we're going to pumice, slurry, clean the tooth preparations, rinse it off and dry it, and cement the restoration, and it just looks like tooth structure. And all we did was mill that out of the disc for that. So really nice that we can get those kind of results. I ended up doing this all digitally with a patient that was flying in from out of town. And then probably the most exciting material we have now then is the Zircad Prime material, which goes from 3Y to 5Y, which is really kind of the ultimate material, especially if you want to do bridges. Pretty amazing. They were able to add things to each of these and get them within the same coefficient of thermal expansion. Again, we can, it's crazy to me how we have that 20-25% shrinkage and you can still get it to fit onto the onto our teeth or onto our implant abutments. So with this then, we can have a stepless gradient on there that just, again, by the optical properties that we inherently have with the transitions between those 2 different forms of zirconia, we get very nice results with that. And I'm shooting pictures one afternoon and going, man, this just looks like tooth structure and that natural transition for there. So a study we did with Andrea O'Day, we were looking at these kind of newer materials, and comparing them all the way up to the Emax Prime material. And then we took layers within that and measured the strength of these materials. So for the Katana, pretty good translucency down, let's call it 750, 760 megapascals, so quite a bit lower than we might want to use. The Lava aesthetic gingival material or gingival level was about 875, and then as we went to the up to the incisal level, it was still in the 800 megapascal range. Looking over here at the multi, we go from 1100 to about 800 megapascals flexural strength, and for the Zircad Prime material, we go from about 1200 down to about 750 in that incisal region there. And we'll talk about how we can position or nest our materials in there. So we're going to talk about this afternoon, or sorry, this morning, this new material from BSM that is really interesting in how they make it work. So they have several patents, as Ed was talking about. One of those is the way that they have this interlacing in here, this interleave thing, so that helps to make an invisible transition from layer to layer in there. So again, that's kind of tough to do that and not get porosity. It takes, you know, very, very, very thorough processing system in there. And so that's always a concern. I have not got around to testing it yet, but from the homework that the company has done and the patents that they got on it, it seems to be working as they have discussed. So with that then, and with their system, part of it being more homogeneous in there, we can create a seamless gradient of that. And so one thing I wanted to talk about is you think about your disc, and then their system also goes from 3Y to 5Y, is what we'll do is we'll position this. So I need to use a 28 or 30 millimeter high disc on there so that I can rotate this. And this is going to be almost all 3Y in here, maybe a little bit of 5Y there. But up here, again, where I have only 1/3 the biting force, right, on there, then I can have more of the 5Y in that and create those aesthetics. So I just want you to think about it. No matter what system you're using, is to consider how you nest those bridges into the disc. So, all right, so here's the Aconia 3D multi-layer material or master material, and what they do is they've got 6 layers in here, and with the technology and the application process, they're able to also create seamless or a natural gradient transformation within those levels. Now what they do is kind of interesting because they're doing something that's more complex than the other systems, in that if we look at it, they will actually have 6 layers within here that also then, the way they make it, will give us a seamless transition from the gingival up to the enamel. And now what they do is within each one of these layers, they are then going to have kind of simultaneous 3D gradients within that work in both in terms of the strength, the translucency, and the chroma of the material. So now you have something that's a lot more complicated. You don't have to do that. It comes in the disc form on that, but they have done this very ingenious process of having transitions within each of these layers on there, and then are able to, again, like the prime material, go from 3Y to the 5Y up there at the incisal edge. So whether you're doing single crowns or you're doing full arch implant supported bridge, you've got that strength in the material, and then you've also got really beautiful aesthetics in it And again, you mill it out of the disc, but of course we're going to do pre-sintering coloring on there so you can get as fancy as you want. If you want to put a craze line in there, maverick colors, white hypocalcifications, easy peasy, just painting that on there before you sinter your ceramic restoration on there. So this really does allow us to do digital artistry with the advantages of a monolithic material that's high strength, but makes us much more systematic in how we achieve our colors, how it's more predictable, and how it's a lot more expedient than we've had with a number of these other systems, and dare I say lower stress and more profitable for you in order, again, because you've got these tremendous optical properties of these materials. So here's an advantage of the bridge that we made on there, and sorry I've got some dust on my lens here, but then also I want you to kind of look at this, and I tried to make it a little darker. So let's look at the gingival aesthetics on there. So again, what was done with pre-sintering coloring, we can put a little bit of more reddish colors in there for the mucosa. We can create root prominences, just as James Choi was doing with Leslie's case with the Mio material, and the marginal gingiva, both the color and the contours of that all help to make us a more natural looking restoration, again based on the inherent optical properties. And then if you want to enhance that, then with your pre-sintering coloring on there, you're all set to get those kind of results. And then Tony Torres, who was a dental technician I worked with in the 80s, my partner in crime, we wrote a couple of chapters in a book and some articles, and we teach how to do kind of higher precision shade matching. What we are talking about is counting the color spaces, and we're looking for differences as we go down through the tooth. And again, based on all those different layers, there are those 6 layers, and having those gradients of structure, chroma, and translucency, we can create subtle differences as we work our way up to the incisal edges that make it look more natural. And so, again, I think a real advantage with this new material that we have available for us. This is actually an A2 on it, and to me, when I was looking at these photos, these intraorals, I was going, well, it looks a little low in value, but not so. I mean, once we look at this A2 in his mouth, he really wanted these to pop, and indeed they did. And again, we were able to create surface texture to help blend it in, make it look natural, but get, in this case, what Tibor wanted for his restorations. Kind of matches his personality. He's a very interesting guy, but again, you saw how those looked when we were in close in the darkness of the mouth, and very natural looking, so we can have these higher value shades like an A2 and yet still have natural translucency contained within the material. And again, following all these steps in the process for making these restorations. Here it is with a higher flash on there, and you can see, okay, it looks like it is fairly bright, like an A2, but still has that natural translucency in the material, whether we're doing the full arch or we're doing, in this case, single implant restorations using and making abutments and then milling those out with the individual crowns. So they have within their system, they've got the disc, that's the Icona 3D Master for that, and they also, like all the other companies, are going to have a coloring system as well. So we've got those advantages of what we can mill from the desk, and you can get as fancy as you want to get or keep it simple in there. Again, that's all available for you if you want to be really artistic as you're working with this. And like all the other systems, it's pretty simple, goes pretty fast in terms of being able to provide this characterization, and they have a nice collection of colors that you can use for that. And here's just an example of what they call a live case. And so we can go ahead and do the different levels on that, the gingiva, the occlusal aspects, and then center it again with monolithic restorations and get a pretty natural looking appearance of those. So and now that we think about this, then we've got this very cool new way of making zirconia, a more detailed way, but very natural looking, that now I'm going to say, from what we've seen so far, puts us on a par with the Emax Zircat Prime material, and is, I think, very promising in terms of the effects that we can get and the natural appearance with that material. So now we've got a winning aesthetic combination of the discs that we're using for this, the pre-sintering coloring, the artistic coloring, and then if you want to do stain and glaze afterwards, then go ahead, feel free to do that. And these are thicker than like a metal ceramic stain and glaze, so they tend to be more durable as we work with that material. I'm going to say it's not quite a Mio type material, but I have not worked with it enough to be able to really make any comments with that. So quite an interesting material that we have available for us. Again, you can get as creative as you want to get with the material. So any questions before we go on to the next section here? Forcing to restart. Okay, so we're going to go over this clinical case that we did, that I worked with Dr. Haddad to treat Tibor, but he's been a multi-generational cross-resident patient. I think he's been coming to us for about 3 years because of some failures, some implants that did not osseointegrate, as well as some other problems that we've had with him. So it's been a long course, and then we've had periods where he's kind of disappeared for a matter of months. So Dr. Haddad helped us to bring it home here, and it's just been so much fun working with her with this material and applying the techniques that we typically do. So he's a very interesting guy. He's actually fun to treat. But he presented original to, I couldn't find a picture of Marco, and I've got him all over the place, but I couldn't find him, with Marco Bergamini, who's now a faculty at Texas A&M. It's not Baylor anymore, down there. So he started out and treated, he's gone through a lot of changes with his hair over the time here. So this is how he originally presented. He's got some problems with super eruption, reverse plane of occlusion, as well as some really severe super eruption on his occlusion. And so that's one problem that he has. The other problem is he's got a fair amount of caries. At least when we're considering our reconstruction, though, at least we can think about not having to change his vertical dimension of occlusion. Sorry. All right, that was bugging me. Okay, now let's go back. So we're going to work at his existing vertical dimension of occlusion. So that kind of removes a possible factor that could be a problem with our patient. So we're going to work at this vertical dimension of occlusion. His lip support, everything looks pretty good for that. And then we've got a lot of breakdown. We've had a fair amount of resorption or loss of bony structure in here. Irregular plane of occlusion, where he's not showing much of his anterior teeth. We can see then when we, so I used to teach courses when I was director of the grad pros program at UCLA, fully adjustable articulators, setting at D5A. You don't have to do all that stuff. The two things I need are, number one, the Cois occlusal facial analyzer that works with my Panadent articulator. It's basically, comes from dentures and then has a way of connecting it with a clutch. So that when I now have the mounted cast, then it's just as though the patient's sitting with me. So I know where at the horizontal plane of occlusion is, and I want to know where the midline is. And then if I record centric relation at the vertical dimension of occlusion I'm working at, you don't need to have a fully adjustable articulator. Or as Harold Chevelle said, you can use a semi-adjustable articulator if you have a fully adjustable mind. So the midline's good here, so we can work off of that. But we do need to correct his plane of occlusion. So we know that the upper incisal edges and cusp tips should follow the shape of the lower lip, kind of a general rule for the smile line for our patient. And you can see that he's violating that with, I don't know, what is that, 6-7 millimeters of a super erupted number 3 for that. Those are hopeless. Those are going to end up being extracted. And we're thinking we like the length of the centrals. We might add a little bit to them, but we're going to start out using this length for that. And here's the general plan, we have to take these two sick implants out. So now we're going to have a huge defect in there, and we're going to have to graft that. We're hoping that if we use a tilted implant approach, up here, still solid basal bone. So that's much more predictable than if we're doing sinus grafting. We know from the clinical studies, even in highly experienced surgeons, the success rate of implants in grafted bone is about, in this one clinical study at 10 years, is about 86% for the implants, versus in basal bone or natural bone in there, it's about 96% success rate. So that's the advantage of the All-on-4, is that we're going to use this much better bone. And Ole Jensen, who was one of the co-founders of ClearChoice, actually wrote 2 books on sinus grafting, and he said with this technique most of the time you don't have to graft. I do want to call to your attention, very highly pneumatized. He's got a gigantic sinus, and what we found when Marco and I were analyzing his cone beam CT, we're going, wow, his sinuses come forward this wall, but there's actually kind of a cone in there that comes almost all the way up to here, which then would prevent us from putting our implants as far posteriorly as we would want. So we're just thinking, just when we were looking at his cone beam CTs, that we are probably not going to be able to do a zirconia bridge on there like we've done with our other patients, because we cannot have a big cantilever like that for our material. So we are planning on, we're probably going to have to mill a bar, and then we'll make the zirconia superstructure on top of that, and then we can at least replace, because he smiles pretty wide, at least we can get a pontic there, if you will, back to replace the first molar and restore his aesthetics that way. So that's the plan, roughly, for what we're going to do for him. And again, high caries risk for that. these failed implants, 9 millimeters of bone loss, periodontitis, non-restorable maxillary dentition, and then partially edentalism with aesthetic and functional compromises. So we've kind of come up with a plan, Marco presented this in our Perio-Cross conferences there, of doing the explantation of the failed implants 8 and 9, doing bone grafting, and we're not going to be putting the implants in this time because it's not looking very good as being able to get a reliable placement of the implants at this point in time. So we use the Ole Jensen rule in that we would like to have at least 120 Newton centimeters of torque with my 4 implants. Okay, so if we can't get that torque, then we're probably not going to be loading it. So that's kind of our threshold. And we were talking the other night about, wow, are 4 implants going to work? What happens if one fails? Well, in my experience, I didn't show that data here, but we had for 474 arches, we had about a less than 1% failure rate of our implants. And also then, let's say we have one of those 4 implants that fails, we usually discover that when we are removing the temporaries, retorquing everything down, and then making our final impressions, that we then have what we call an early failure. So that's okay because I have 3 osseointegrated implants. So what we do is typically take out the implant, put it somewhere else, modify the temporary, and my rule is as long as the patient can leave with teeth, they're happy. They don't care how long it takes, as long as every time they leave my appointment, they've got teeth in there. That's what's absolutely critical for our patients in my experience. And then we're going to go ahead and we're going to make a surgical guide, and we're going to do a bone supported. I don't like using tissue supported surgical guides if I can avoid it. And then do a conversion prosthesis. We're going to do single tooth implants in 19, 29, and 30. And for this then, we're going to make custom abutments. We're going to talk about the designs for those. And then do a maxillary implant supported fixed prosthesis as a prototype. So we would put that on our milled bar, and then we'll just glue that on there with something, and we'll have the patient wear that for a couple weeks. We evaluate it in terms of our factors for occlusion, what we think is that we need to make aesthetic corrections on there, and then the patient, of course, also evaluating it. And so if the patient, that's the first thing I say to them is, we have complete control here. We're making a whole arch of teeth. We can make them any color you want. And they'll go, well, I actually had my shade guide. I took off B1, and then some patients actually know about and ask for B1. But the thing is again, if this is my prototype, I'm going to make the provisionals out of B1, and 60% of the time the patients go, yeah, Dr. Sorensen, I think you're right. Let's go to the next level down, and A1 looks very clean, looks normal on there compared to the B1, but we test that out, and 40% of the patients love it. Okay, they're their teeth, if that's what they want there. And then we're going to do the milled bar, again, that supports the prototype, and then we'll support the zirconia prosthesis for it. So I've been doing this a while. I still like to start out with mounted casts. All right, you can make them out of printed material or stone. I can find, and most of the time, it's a pain in the butt to have to go through all that fabrication, cleaning, and everything. I can pour these up and have them ready to go, but I want to actually be able to sit there and look at it in 3D, held in my hands on the articulator to kind of get an idea of where I'm going, play around with the vertical on the articulator, and then I'll go ahead and get on the digital pathway. And I find this to be also very helpful with the residents too, to help, we're visual people, to really be able to look at those mounted casts and figure out where we're going to go. And Marco, again, talked about, correcting the supereruption and correcting the plane of occlusion for that, for the restorations. So he went ahead and did a immediate denture setup. And we were starting to work with a company called Stratasys. I helped them get FDA 510K approval. So any product that's going to go in the patient's body has to have FDA approval, and it's called 510K. And so I did oral wear simulator tests to evaluate. We ended up with Lee Culp. We evaluated, I think, 14 different printed materials as well as now permanent crown materials. So what we did is he did this setup, and then we scanned it, and then we digitally designed dentures, and we had Rob Cryer at Stratasys in California then print those up for us, and I say, hey, print 3, as long as you're doing it there. Stratasys is an amazing system. They can print 35 dentures all at the same time, different materials, and this also then prints at either 18 or 28 micron resolution, which means it's going to be easier for me to polish that than if I've got 100 micron lines on there that I have to do a lot of removal of material in order to get that smooth for that. And so I probably would have gotten more horizontal overlap in the posterior on there, but he went ahead and did this. And so we end up starting with something like that. And then, so then we have this. So another advantage of this material, it prints the support material at the same time it's building the restoration. And also then each layer, 18 or 28 microns, is light cured, completely polymerized. So when they finish printing this, it's already 100% cured. They do some stuff to it to fixate the colors in it, but it is already completely polymerized. And unlike all the other DLP printers and those guys, they're only about 65–70% polymerized. Now I got to put it in a light curing box, and that's where you get all the distortion in your complete dentures. And you've probably seen, if you're into dentures, even if you're using the carbon system with all these various systems. So my brain is not working. Lucitone Digital, you'll see they have bars going across, 2 bars that go buccolingually and another one anterior posteriorly to help stabilize this because you have all this distortion going on. But I want to use an automated system. I do not want to have to do handwork with the restorations and grind that off. And also a huge advantage, this builds it flat. I don't have to have that 45-degree angulation with all the scaffolding and all that rubbish that I have to grind off and cut off. And this stuff is super easy. You just basically water blast it off. So really a cool material. I think at this meeting, or it's coming in the next couple months, we'll have the 4th dimension where you can design the individual tooth with whatever shades you have in there. Right now, you just say, I want an A3, and then you can print the tooth, and it's monolithic, so it prints from the base up for the teeth on there. One of the big problems with all of the printed materials is they're very challenging to polish. They're a pain in the butt to polish. This material actually polishes really well. I find the most challenging thing is to polish those inner dental papilla and get those smooth and polished. One of the main problems right now is with most of the systems, I print or mill the teeth, I print the base, and then I got to glue those together, and now I have an interface that gets stained, or I may have voids, or I don't get it seated down properly, and now I got to monkey around with adjusting the occlusion to get that where I want. Turns out this material, it's called TrueDent, actually polishes up very nicely for that. And again, using the rubber wheels to get this versus, and then using pumice on the rag wheel. And then in all my fixed and removable kits, I've got a 1-inch rag wheel. I don't even need to put acryluster or anything on it. That'll give me a little shine for my provisional restorations, and not a bad looking denture in here. The thing is he's pretty hard on anything that goes in his mouth, so we'll see. We'll see how this holds up for him. And then we went ahead, and so Lee Culp and Marco and I, we sat down again by TeamViewer, and we designed, placed the implants, figured everything else out, and then went ahead and designed the surgical guides, and then Lee actually printed those out. So I was so excited. I go, oh my God, look what he made here. So I've never gotten this from a technician before. So here we're looking to floor the nose and the sinuses, all right? So central, lateral, canine. Look how far, and sorry I don't have the cone beam CTs available, but we got this funky little thing where the sinuses are coming way, way forward for that. So even with the tilted implant, we're going to have not nearly the same AP spread that we get with the All-on-4 tilted implants, which is usually 18 to 22 millimeters, which then helps us to eliminate cantilevers. It's less stressful on the bone structure. And so we're going to fixate that with these 2 pins that go into the structures. And again, we put that, avoids vital structures, nerves, blood vessels, as well as hitting the implant. We're putting that in between there. So this is designed with the tissues that were on there, and then is anchored into the bone. But it's very critical how you start out with this, that you secure this. And I was actually kind of in and out of the surgery, and I wanted to be the guy that secured this while the oral surgeon went ahead and put the pins in. And what you want to do is you put one pin in and you put the other pin in, and you're done. You don't take it out, monkey around, because you never get it seated back to the correct position, which of course really bummed us out with these tremendous guide system here, and this really cool system for it's a denture, but it's modified, so it makes our life a lot easier for when we remove the materials we don't want. So this pin position then is all precisely worked out with our digital design systems for the original base, and then for our conversion prosthesis on there. These pins go into those same holes and lock that into position. And then you can see what he's done is he's cut all this away in the palate. So that's going to take no time at all to go ahead and section that off after we've connected it to the implants. I actually like to make my holes smaller, and then I'll make them bigger if I need to, because like over here, that's a little thin. So when I'm positioning my multi-unit abutments, that's a very important procedure. They usually go in 60-degree increments on there. If I'm going to err in any direction, I want those to go to the palatal. I want to maintain like this, very nice thickness, a little thin here, but okay, we're in the cingulum in there, and then we just have this thin area. And I've had lots of those break off when I was during the provisional phase for my restorations. And then it looks like we had something applied on here that would give us that shiny, smooth surface. It turns out some of that, I can't remember what it's called, TPO, there's some nasty stuff in some of those materials. And in Europe has said that those are no longer allowed to be sold in the European countries. Okay, and then also, okay, it's not that big of a stretch then to make a denture, just in case, for our patient, should we not be able to deliver the prosthesis that day. And we've got that other one with all those slices in there. So this is a damn disaster here. So the anchor pins were improperly done. I don't know what was going on with this kid. And then he laid a surgical flap, but he did not reflect it back far enough. And then when he was repositioning it, it turned out that he had a couple of millimeters of tissue on the palate that got underneath there and threw off the position of our beautiful surgical guide and prosthesis there. So that ended up being a disaster. Okay, so that was, we had some problems with that. Also, they had done a lot of bone grafting, and I've never seen this before. It was smaller than a kernel of rice, but it was like, and it had been, I think, 9 months since the tissues were, since the area was grafted, and it was kind of granulated and not bonded together like you usually see with bone. And we had some areas that had soft tissues instead of bone that were grafted in there, and then low insertion torque values. So we don't get to use our surgical guide for that in order to deliver our provisional prosthesis. So no immediate fixed provisional prosthesis today for that. So Lee had made that one, but we had produced some with the Stratasys system just because I wanted to test out the TrueDent material. And we went ahead and delivered that. This was actually fabricated by a lab in near San Diego. When we were having our first meeting with 10 big labs that were going to be using or buying the Stratasys system, they, I can't remember his name, but he had a lady that did polishing and dentures, and she overdid it, right? So we've lost the contours of the teeth on here. Okay, it's a immediate denture, and we're going to be using that to convert to the immediate fixed prosthesis. But you don't need to polish this as vigorously, and you don't have those 100 micron steps on there or layers that you need to get off. And not bad looking there. And the problem is he gags with anything, what's there, posterior to the second premolar. He's Mr. Gag. Even when we're doing intraoral scanning, he gags on there. A real challenge with him. He's a pleasant patient. He's a good guy. But again, very challenging for the work we're doing with him. But it's been a real blast working with Dr. Haddad, doing his treatment on here. But boy, does he stain. So he, whatever he's drinking, whatever he's smoking, a lot of staining. Again, it's been a while. It's been a long time because we actually had an implant that failed. We had to then remove that, then graft it. So we're talking a long, many months on there. So now we're going to go to the digital workflow here. So Dr. Sarah has set this up on that, and we're for the Grad Pros program, they have a T5. I guess now they have a T6, Trios 6. I'll have to check that out. I still have a Trios 3 that actually in our studies was more accurate than the 4. Again, our residents are doing this day in and day out using the intraoral scanner for various procedures there. So we've gone ahead and we've scanned that area. Then we're looking at the tissue areas, and it's got actually nice keratinized tissue immediately around the implants there. And we're off by quite a bit on our midline for that. When we went from the denture, which lined up very nicely, a lot of things going on. It's easy. It happens to me a lot too. That's okay. He's got the provisional. He's a happy man. He's got a fixed bridge in there during this healing process. And then we put the new implant in and just drilled the hole, modified it, and added that and let that osseointegrate. Again, he's always got something that he's wearing. He actually could not wear the denture. I think he'd bring it in with him sometimes just to kind of show us he had it, but he was very uncomfortable with the with the denture. Okay, so we're going to go ahead and scan that, and for you clinicians out there, it's really important that, you know, what does it take? 6 seconds typically to scan the bite, but you need to go in and check that you've got those blue actual marks of contact. Down here, you can click on contact only. So, you know, this thing is big, you've got that in the back of the mouth, and you're going forward, and you tell the patients to stay biting down, and half the time, I don't see these contacts that I know I have. So, you need to, no big deal, delete it and do it again, because it only takes 6 seconds, and do left and right for the full arch on there. But again, really important that you make sure that you have an accurate interocclusal record or bite for your patient there. We go ahead and scan the other areas, and here we're going to do reverse scan. So we have these special scan bodies that will then connect with our prosthesis, presuming that that immediate fixed provisional has been accurate. And it usually is, considering that you drill holes and then you add material around each one of those. So you're probably going to be pretty accurate for that. And I feel very comfortable with using that. And turned out it was very accurate with the milled metalwork framework we got back from the VSM technology team on there. Easy peasy, we can do that outside the mouth there to go ahead and scan it. Go through our various scans for that with our tissues nice and healthy. And then the next stage then is we get from that scan of our midline that's way off, we make all these corrections in it, and now, especially with the midline being off by a couple of millimeters, I want to analyze that as well. So we're going to go ahead and make a prototype and analyze that. We made some modifications on that, trying to correct this plane of occlusion so that we could get him where we wanted him to be for that. And then go ahead, and if you made changes in the prototype, no big, go ahead and scan it for that. And this is just so amazing that you can do this with scanning. It's really fantastic. And then have a way, because we're working digitally, to be able to communicate between the doctor and the technician. It just really, really helps things out. And you can discuss all sorts of points. Doesn't take long, but it sure enhances our communication within the team for that. And then we're going to go ahead and so BSM has these cool little scan bodies, and they're still calling it ITI, which is what Straumann was originally called. And I'm sorry, I think I've lost the drive that had that, but they have these little holes on here. And you know, what's the brand called that has the big arrows of metal in there? Anybody remember? What?
Nexus.
Is it Nexus? Okay. So what these guys have is even a simpler system with something that sticks out about 6 or 7 millimeters. You can rotate that, position that, so that you can have it wherever you want it. And now I have a more accurate scanning system because I have maybe a millimeter between the little arms that come out from the scan body. So very cool system on here. And for those of you who have short, fat fingers like me, I absolutely love, there's a system called AnthroGear. It's more expensive, but it has 5 Newton centimeter increments on here. But what's great is this is a contra angle. You can get a whole variety of tips in there, like this stupid little Straumann one that strips out easily. But I can go back to a 2nd or 3rd molar, put that in, and I can have my assistant do it, and I'm just manipulating things, or I can do it. And then when we're at Clear Choice, we really expand the duties of our dental assistants. So I would have the assistant go ahead when the patient was coming back for a metal framework try-in, but we'd also have the tooth set up on there, and she could go ahead, use our AnthroGear, and and have no possibility of fracturing the prosthetic screws, which we want to do at only 10 Newton centimeters. That I think is $800. I found some on here for like $300, but really recommend something that'll make your life a lot easier for working with those. And then they've got these special single tooth ones that are whatever the other company from Brazil that Straumann bought for partially edentulous patients. So we're going to go ahead and write up the lab prescription. We've talked about what's been going on, and again, we treatment plan with Lee doing that. We've modified the prototype. We're going to talk about what we want from the technical team in Chengdu. So here we have pre-op. When he was having the surgery, I played Cedric of York, medieval barber, so I trimmed off all his beard so we could get in there and work, and seems to be getting smaller and smaller amounts of hair for that. This is the prototype pre-adjustment. Then we went ahead and made some adjustments to try to correct that plane of occlusion in the posterior area. This is what it looks like at the different levels. And then we made this big modification here, so we follow that shape of the lower lip. You have a lot of patients that are asymmetrical. One side is steeper than the other. So within reason, we try to do that. I like doing lingualized occlusion, so I have my lingual cusp and a denture. They give me balanced occlusion, but I can cheat on the aesthetics and rotate the buccal cusp up, but I still got my occlusion on the lingual cusp. So I love the Ivoclar lingualized occlusion approach for those. Okay, so we have modified the buccal corridor by bringing that up and improving that situation for him. And then we've done the try-in and seating of the prototype that verified that. We're going to make some small additional changes. And one of those is to increase the length of 8 and 9 by about 1/2 millimeter. And then talk about where we're going with the mandibular crowns. Number 19 is a little funky because it is positioned out to the facial, but since I'm using monolithic zirconia, I still have a wall thickness of about 1.5 millimeters, so I'm not worried about having a screw access hole that comes out kind of through the buccal cusp for that particular tooth. And so we ended up modifying that or bringing that in, because at all times, whenever possible, I want to always have screw retained prostheses for my patients. Now something that is, I think, super important, and I don't think any other faculty in the School of Dentistry that I'm working with at the University of Washington have an appreciation for that, but that is this very important emergence profile of your abutments through the soft tissues. So the way we're still doing it in our pre-doctoral clinic is they get the stone cast back. It's got the implant analog in there, and then they have the students with the faculty randomly grind away a bunch of stone, which represents the soft tissue, and invariably it comes back and it's too wide. It hangs up on the gingiva. Implants do not hurt, and that definitely hurts when you put pressure on the periosteum. So two things here. So the first set of provisionals we got, they had a gingival height of about 1 millimeter. I do not want to have a restorative interface down there for a cement margin, or God help you if you have to cement that instead of doing screw retain. But again, these are in the posterior on the mandible. Why not make these equigingival, keep life simple on there, and just make a straight emergence profile as we go up through there. So I will measure the height, let's see, I've got that later on. We'll measure the height of the gingival tissues, which I have drawn in the pink line in here. and look at where the bone level is on it. And again, you know, if you come right out here, see this is bone in this area here, so that is potentially causing a problem in that area. And again, because the technicians want to make a nice emergence profile to go up to a 10 or 11 millimeter mesial distal width of a molar for that area. So we're talking about, we want equigingival margins, we want a straight emergence profile for the numbers that we're putting in there, and I want them to use the Besmile pre-milled blank. So that means the interface with the implant is precision milled at the factory, and now I've got this big tube or solid cylinder of titanium, and now I can make whatever I want, whatever I desire from the laboratory, and it doesn't cost very much because titanium is very cheap, even though that's supposedly the high level for a number of things. Okay, cross-sectional configuration. I want it to be more or less square with rounded corners, and I want a vertical rounded groove as an additional anti-rotational feature. So the first set of definitive crowns, we got zirconia with a gingival height of 1 millimeter. It was almost round, so Dr. Haddad and I could spin both of those maybe a millimeter. So that's completely unacceptable. And again, why do they want to put the interface 4 or 5 millimeters below the crest of gingiva? So this is the temporary coping, and so when you are ordering parts, I don't know if technicians are familiar with this, but you can ask for different gingival heights. Usually it's in 1 millimeter increments. Some implant companies are clueless and they don't give you a choice, and they just stick you with that one gingival height of about 1 millimeter on there. So think about that as you're working. We want to have what's called the biologic width. We'd like to have that restorative interface. If I'm cementing zirconia onto here, these are provisionals, is I want to have that at least 3 millimeters away from the bone. And in this case, I don't want to have it buried under 4 or 5 millimeters of soft tissues. We know this cement inflames the tissues on there, so we want to be as biologic as possible. Again, with that gingival height of 1 millimeter, and you can see there's bone all the way up there for that. So the ideal location is up here at the gingival crest, not down here. Easy peasy. Make it straight, make it vertical, and just widen it out to when you get up to near the tissue level for that. And so when you want to think about this, and typically what I have the students do, I sit down with them, we pull up the radiographs, we measure the tissue height, and then depending on where we are in the mouth, am I in the aesthetic zone? Okay, I'll go a little subgingival, but in the posterior, especially with, I don't know, we got crown preps that are 7 millimeters tall in there, the crown is going nowhere for that, so we can go ahead and lengthen that up. Whoops, something happened. I lost my design that I was showing you in that first slide. Sorry about that. Have to redo that. So this is what, with the lab prescription, what I requested of the technical team at BSM, this is what I got back. Exactly what I was looking for. Squarish, anti-rotational just by the shape of that, rounded corners, and then grooves that are in here. And so you'll see that when we get to the actual abutments, then, and I think they sent this to me, the images, and I said everything's good except for put a bigger groove in there. And these are the pre-milled blanks. So again, high precision, milled at the factory, and then you can do whatever you want with this. And when I was working with Biodenta, they called it the Prefab 4, 2014 or 2015, we did validation studies for them with Hung Sak An, one of our grad cross residents, and we found that it was very high precision within 25 microns. So, And Sarah, Dr. Townsend goes, well, I think we can do better than that with waxing and casting. Right? So I don't think so. So again, just a wonderful thing here. I have complete control to do whatever I want to design on this, whatever dimensions I want to work with for this. And then I'm just showing here with the analog and how that fits or adapts to that. Okay, so I'm very familiar with the 3-shape system, very popular system, maybe even more popular with a lot of technicians, is the ExoCAD system. Whatever works for you is fine. This is a great system. So they're going to see what Dr. Haddad and I requested in our lab prescription, and then they're going to make that apply to what we're looking at. So I want you to look at where those holes are. First, premolar, right? So that's way, way more anterior than we usually see in our patients, and absolutely necessitates that we make a metal substructure to support that, because this is not going to survive no matter if it's all 3Y zirconia. It's not going to be strong enough to do that. And no problem. Again, we can design this pretty easily for that system. And here's what we're looking at with the design that we were after, with those modifications that we requested and made in the prototype prosthesis. So here we have the design of the bar. We're looking at a 10 to 15 degree taper. I don't know, this is even in the narrowest or shortest area here, we're still at about 8 millimeters. So not a problem on there. And the fact that even if it's 15 degrees, that you've got this arch going around there, it's going to make it very retentive for the cement. And in fact, will create challenges for you to seat that metalwork all the way down in there when the lab did such a beautiful job of making a nice even edge on the intaglio surface, as Steve Wagner requires for that. Also then, we know that when we have a lot of vertical differences on our implant, it tends to reduce the accuracy. So in something that's real extreme, you may want to do a verification jig just to check that out before you commit to this. And you can see they've designed it here. They put surface texture and all that in the prosthesis. And we're liking the shape of it. I like how we're going up here in the buccal corridor. And here we can see the design of the metal. It's not gold. I guess it could be anodized with the what we call the superstructure of zirconia that has these parallel walls that are going down over the milled bar, and then has the screw access holes. So we have a good thickness of the ceramic all the way around in those areas. So here they've gone from the CAD, the design, now we're going to go into the CAM system. Kind of an interesting method of securing it with this. I have to ask more questions about that, but they don't fall off. And so we're going to go ahead, and you can see we've got these, well, you can call them screws on there, but remember, one of the important things is you do not want to cut those screws off until after you have sintered your zirconia. Because if you just have the body of your prosthesis, you're going to get all sorts of distortion. So absolutely requires, for the stability of this, is with these screws on there to prevent distortion as you're going through that. If we're still doing 10 or 11 hour sintering process for that. Usually we put it in at night and come in the next day and it's ready to go on there. And then positioning the prosthesis in here. Now this is a little strange because I thought they had a 30 millimeter tall disc, and Tibor is pretty high from this long flange that he has in here, and that one implant that's another 3 millimeters more apically. So I think they have probably added something on there in order to do that. But again, we have that advantage, again, knowing that it's more 3Y down here, so I would still rotate it like they actually did within the material. And they have all sorts of milling machines, printers, and all that kind of stuff. I have no expertise or experience with that. I can only say what I've seen in the results of what they fabricated for us with their systems. And unfortunately, we're doing what we call an inverted T-bar for another patient that Dr. Haddad is treating. And what we do is make upside down. We have metal on the intaglio surface. We've got maybe a 2 millimeter flange, and then we've got vertical, very parallel walls on there. And we are milling those out of the iVotion system, which has the advantage of being all one piece, and also the milled PMMA materials are stronger than the printed materials for those. Okay, so we're going to have to go ahead and center this in that, and it's all controlled and directed by the company. Okay, so this is what I then got back from the tech team here, and that's what I'm talking about, is a nice seating groove that's in there. Now, you can't make it like a 169 burr, because the smallest milling tool for most of these milling systems is 0.6 millimeters. So if your clients, if your doctors are cutting sharp line angles up here, it's going to be over milled, and you can look inside the crown and you see kind of a tube going around there. 2 months ago, I had a student, he got his prep signed off on a premolar with another faculty member. Sorry, it was a molar. And then now I'm going to be delivering it with him, and I always have the students measure the thickness, the occlusal thickness of their temporary crowns after they've adjusted the occlusion to verify we have enough occlusal reduction. I've been doing this for a long time. I still find half the time I have to go in and take a little bit more off. Easy peasy, just measure that. And then if I've already scanned it, then I can go ahead, modify the prep, 3 seconds to trim it off, and then rescan it in 5 seconds, and you're ready to go on there. If they have those very sharp line angles like this, that radius is maybe 1 or 2/10 of a millimeter, not 6/10, so you end up seeing this over reduction. In this kid's prep or crown that he got back, I'm going to measuring it. Whoa, it was 1.5 everywhere else, and then in the over milled part it was 0.3. So something you just need to work with your doctors with, that they need to take that red banded finishing diamond, and I just go across the prep like a 45-degree angle there just to round those up. It's not going to affect the retention or resistance form of your crowns on there. So now I've got rounded squares here and that groove, which gives me very precise seating. And the work that we previously got, you could very easily put the wrong crown on there, and it kind of fit, but they all rotated on there too much. Okay, so they went ahead and milled that out of titanium, and then they did gold anodizing there, and again with these nice features, plus they put these little grooves, rings around there to provide additional retention for them. So very happy with the quality and the adaptation. No, not the slightest bit of rotation inside the preps. And then we went ahead and they designed crowns. And I would like to have, and I have the students write this down in the lab prescription, I want an area of proximal contact between molars that is 3 by 3 millimeters, and between premolars that is at least 2 millimeters. And I'm going to say probably 80% of our patients, we analyze it before the implant's going to go in. What shape of the adjacent tooth do I have? Especially maxillary premolars, the average mesiodistal width is 7 or 7.5 millimeters. If I have a tooth like this, then I have to take off a 0.5 millimeter on the mesial and 0.5 on the distal. Excuse me, that's another millimeter that my surgeon will have to work with. Or you make a guide and they don't use it. Well, that's oral surgeons that don't do that. They're clairvoyant. But if you have the equivalent of guide planes prepared on there, that's what they're going to key into when they're placing the twist drill doing the first threads in there. For those of you, at least I'm familiar with the 3-shape system, when I'm designing a crown, it gives me a bright red square to show where the contact is. And whenever I'm teaching a technician, I say, make it 3 times bigger than what they're making it at. Because if I have just a little point contact, yes, I'll snap floss, but I'll still get food jammed in here, and I'm speaking from personal experience in me. So I would redesign this, and that's what we did, you know. And again, they sent us the design. We asked for the modifications. Yeah, you can get some in here, but again, with that path of insertion, you can't modify it, and the teeth were already, we already had the scans on it. So you can see they followed our requests and said, you can get your Proxa brush, dental floss, whatever, and clean there, but now I got a nice long contact for that. And here we have it sitting with the milled abutments sitting in here. And one point I might make for you technicians is if I have to push this down because it's engaging with the elastic, the rubber gingiva moulage on there, then I need to take that excess material off. So typically we'll have to grind and make it, again, a straight emergence profile because if I have resistance in the gums, I know I'm going to have too much pressure on the gingival tissues when your doctor is going to be seeing those into place. And I check proximal contacts with a Mylar shim stock marking material. Dental floss is okay, but it's too thick. It's 40 or 50 microns. Plus, it does not leave a mark. So I'm guessing if it's too tight, I need to make adjustments on there. And then also, if I have a Mr. All ceramic, but the one time I use metal ceramics is for single tooth implant crowns. So I will use finger pressure, and then I take my hemostats with my interproximal marking tape and pull that through to evaluate my contacts. And then once I've done that, then I'm going to cut 2 little pieces, put those in between the teeth, and then tighten down the screw. And that, when you tighten the screw, it goes down a little further. I got too heavy a contact. I mean, if it's screw retained, okay, I can always undo it and grind a little off on there. But sometimes it shifts in the other area, and now I have an open contact. So that's just an additional way that we can verify your proximal contact. And here we've got our funky number 19, but not a problem in terms of the thickness of my materials. And okay, I'm missing my buccal cusp on that area. But also then, when let's say I use a 30 micron finishing diamond, I do that for everything. I just use a different shape of burr. Typically I'll use a 2 millimeter diameter crown preparation burr. I'm going to grind on those marks, but I don't want to take any material off after I have gotten the correct amount of proximal contact. So what I'm then going to do is go to the Dialite Fine, which is going to give me some luster, but it's not going to take any significant material off of those areas. Okay, so they did a nice job of making our bar. We want the intaglio surface to be very highly polished, so they're doing that. When we do more cases, we'll talk about, I would still want to make sure that I have a straight emergence profile for my multi-unit abutments on there. Again, I want those to be straight up. I don't want to have any pressure on the tissues as I'm seating that to place. Nice tall walls, just like we saw in our design. Again, then polishing those surfaces. And then once we're going to be cementing it, then we're going to do aluminum oxide abrasion. You can see somebody's fingerprint on here on that. So we definitely want to clean that surface prior to cementation, and then no finger grease or rubber glove, whatever is on your rubber glove contaminant on those surfaces when we're going to cement. Again, I'm pretty comfortable with the amount of surface that I have on there. Again, keeping the sprues that are on here to stabilize it for firing, and then the framework goes down in there very nicely and we have a beautiful fit for the restoration. And then after the application of coloring things and all this, or stains if you want to use that, then we have a metalwork that just drops right down in there. And we do want to then check this intaglio surface. So I'll typically end up using pressure indicating paste on that to make any adjustments that are necessary, and then polishing up that surface, because smooth is good in terms of plaque resistance for that area. So here, Dr. Sarah is trying in the framework. We just go in there with a Sharpie and we mark any areas we have excess contact. We're going to use a 12 fluted carbide burr. Again, it has, at least for Brasser, it has a red band on it. Works very nicely for efficiently cutting metal off and kind of polishing at the same time. And I always want to get the metalwork and the superstructure of zirconia as separate pieces. I do not want the lab to do it, because if I have to play around with all this stuff, I'd rather have it under my control and then cement it when I want to cement it on there. And again, even with their lab, they were kind of pushing us to let them cement it, and I put in all capital bold writing there, please do not cement it, let us do it here. And I just wanted to show you, this is, I think it's called TEPI, T-E-P, and the other one I use is Speed Cem, and there are other resin cements that are recommended by the companies for cementing implant prostheses. But now I can clean all that off outside the mouth, no problem, versus having a hard time if we have to leave it in the mouth. Okay, so now we've got the completed prosthesis, we've got our finish lines, everything is looking pretty good for that. And then we have our completed prosthesis with our tissue coloring on there, with a nice incisal translucency, a differential or gradient in the color of the teeth. And very happy with the smile line buccal corridor that we got, that we worked on at the provisional phase and the prototype to get what we wanted for the restoration. And then we're going to go ahead and deliver the prosthesis. So we're going to check and see if we have any blanching, or in this case, you can see we had kind of a pressure area from the provisional. So we're going to go in and just mark it on the outside where we need to make modifications on there. This is the Dialite ZR. This is a fantastic polishing, especially the one with the magic fingers. Amazing how nicely you can polish all the grooves on the occlusal anatomy. And so if you're working, if your rubber wheel, the abrasive, well, now it's medium. If that's not abrasive enough, they actually have this green stone. That's the only time I've gone back to using these. It's in their kit, and it works very efficiently for making these little modifications on there to remove those areas of contact. And then we can go to the green with a yellow ring on it, medium polishing. And after that, we can then go on to the fine polishing wheel. And then we also want to make sure that we don't have undue pressure on the tissues around here, where we had a little bit of excess there. Red banded 30 micron finishing diamond, using the H-shaped one. Don't use the football one that's pointy. Those diamonds, after about 20 rotations, are toast, and then you get metal marking on, dark marking on your ceramic material. So they've got 30 micron and 50 micron. I don't really use the 50, but I use these guys as well. There's usually 2 in there for polishing that. But again, these guys work, but they're not very efficient, and they're gone in no time there, and they're fairly expensive. Okay, so now we're just perfecting our occlusion. Red banded finishing diamond, low pressure, low speed to go ahead and remove that and develop our occlusal contact scheme on there, and a nice natural appearance of our occlusion. again, we just get from the ceramics. Again, he wanted this A2. I think his mandibular teeth are an A3.5 or A4. And so he texted me actually that night, and he goes, "Doc, I love these teeth. They're bright and beautiful." He goes, "I want to do veneers on the lower teeth," and I don't know. With the amount of caries he has on the lower teeth, I think we should just take them out. But anyway, just really neat to see how excited he was over the results on there. A little bright for me, but he was absolutely loving it. And so hopefully today you've seen, learned a little bit about how zirconia works, maybe some clinical ideas, and then also you might want to take a look at this very interesting material that I think is definitely worthy of your consideration for full arch implant prostheses. So I'd like to thank you for your attention, hanging in there, and I'm happy to answer any questions you might have. Yes, ma'am.
Question. You talk about strategies doing the printed dentures. How long have you been using the material?
I started in 21. Yeah, it was still COVID. Yeah.
Have you have any more like breakage or chipping from that material?
No, I have not. I mean, knock on wood. I've only done about 8 or 9 arches of it there.
Yes.
They have made some improvements in the material. And so, I don't know if you're one of those lab technicians, but they have the shoulder dropping height on it when it hits the floor. I saw a video somebody was showing where they dropped it and then they were kicking it around in the bathroom and in the bathtub and it didn't break. But that is a problem, right? It's still, yeah, it's definitely a concern. For me, the wear resistance is a pretty strong consideration for the material. And so it's been interesting. We've tested, we did an abstract last year on permanent crown materials. So we found the Bago Barcio Smile Crown Plus actually was really good. It was like less than half of the wear we saw on the denture teeth. And you always want to have, when you're looking at research and people's studies, you always want to have a control. So that control was a IPN denture tooth, right?
Yes.
So we want to compare against that. And some of the materials were worse, some of them were as good as, but the Bago material was very good. And then you might see Sprint Ray had Onyx, right, which actually was a pretty good denture material, right? Recommended for dentures, but I don't think they recommended it for making teeth on a metal substructure for an implant prosthesis. Got higher biting forces, greater chance of that fracturing. And then they had Tough 2, and then they had ceramic crown. So the good news is somebody was able to get the ADA definition of a ceramic crown. If a composite has more than 51% filler particles in it, glass filler particles, it's considered a ceramic crown. So the doctor can get, I don't know if they told you this, but they can get the full fee that they would get for a ceramic crown in there. And that material we found out was pretty poor in terms of its wear resistance, and that's the Midas system. So it's the viscosity is so high with that higher filler particle rate. You have this. It's a cool concept. We're actually doing some tests on it now. It's a neat concept that you have pressure for that's feeding it and pressing it into the system. So the problem that we've seen is the margins would be fairly well closed. So let's say milled margins with PM7, PM1, which they pulled off the market, VHF Z4 and a VHF E4, that the ceramic margins were sharp, the printed margins, so these are VAT printing, they were closed, but they were 75, 80 microns versus the milled ones are 25 to 35. But then also it was short, right? Because instead of being out here, the margins were rounded like that. So we're, one of my grad students and I are doing a study on that now, which he'll be defending his thesis in the end of May. So we'll see what we're looking at for that. But and then unfortunately there aren't really any clinical studies done on the on most of these materials that are supposed to be permanent crown materials there. I do know that Florian Boyer from Charité University in Berlin, they did a clinical study on titanium implants, on zirconia implants with the Bago crown material, and they had about a 14% failure rate in the first year. So getting better, but in terms of wear resistance, but then doesn't have the strength to hold up like that. So, yeah. Anybody else?
I have one.
Uh-huh.
What was the value for the torque when the doctor will know if the implant will fail or not?
Well, so what I was talking about is you want 120 Newton centimeters total insertion torque in order as kind of a guideline or number as to whether or not you're going to load it.
Oh,
All
okay.
right? Yeah. So, I mean, we really didn't go into it, but if you, let's say, ideally you do all on 4, and you go, well, I want put another implant. My surgeon and I called those emotional implants for the first year where we were putting some more in. You do not want to put an implant in the midline because, number one, all the 4 studies show that it does nothing to improve the support for your prosthesis. And we've seen, I don't know, 5, 6, 7 cases where patients had wicked pain in that area. And I don't know if we were in the foramen or what was going on, but we took the implant out and they were fine, you know, in there. So if you want to put more implants, put them in the back, right? That's where I want to shorten that cantilever. And then if I want to, again, 1, double, triple, and back on the second molar. So even if you put a 7mm implant in there, that's tied in with the other implants, you're going to be in much better shape. Or I don't know if you've seen Avi Vidro lecture, he's doing these pterygoid implants. I don't do surgery, so a little scary back in there. I've had surgeons do a couple of those where we had nothing else and they work great, you know. But yeah, again, you know, 7mm implant in the posterior. Some companies make a 6mm implant, then put it in the posterior there. Okay.
If you have any questions, how come we reach out?
Yeah. So JSORE. I forgot to put the slide in there. Sorry. Yeah, so, ready?
Okay,
Yeah, JSOREN,
J.
SOREN. Yeah, sorry, I usually have it up there. Okay, JSOREN at uw.edu. It might take me a week, but I promise I'll get back to you. Even you.
EDU?
What? EDU, yeah.
EDU?
Mm-hmm. Yeah, University of Washington, uw.edu.
No.
Thank you, Doc.
Oh,
Thank
thank
you.
you. Thanks for coming.